হ্যালো, নাও এখন শুনতে পাচ্ছ? অগ্নি, অগ্নি,
Yes, sir.
অগ্নি, am I audible?
Yes, sir.
হ্যালো,
Yes, sir, you are audible.
হ্যাঁ, হ্যালো, শুনতে পাচ্ছ?
হ্যাঁ স্যার।
হ্যাঁ, sir.
হ্যাঁ, আচ্ছা। এবার ব্যাপারটা হয়েছে কি, আমি তোমাদের ওই রেকর্ডিংটা তো চালু করিনি, সেই জন্যে এরকম হয়েছে আর কি। আমি রেকর্ডিংটা চালু করিনি, সেই জন্যে আমি আসলে ইচ্ছা করি রেকর্ডিংটা যে করিনি আর কি, যে প্রথম দিন তো এই যে দেখার জন্য ট্রায়াল। ঠিক আছে, আমি একটা জিনিস শেয়ার করছি, যেটা শেয়ার করছিলাম সেটাকে এক্সপ্লেন করি খানিকটা। Now it is visible orbital structure. Hello?
No, sir.
Not visible. Okay, I have not shared, that's why. Okay, just a moment. Because I have to share, because I had to cross check the what's the problem. Because earlier you were replying yes sir, yes sir. Then what happened? I don't know. You tomorrow, because I have to say, because I had a question. What's the problem? Because earlier you were replying yesterday. That what happened? No, chat box এগুলো allow করবো না, খুব মুশকিল হবে। নাহলে এই চ্যাট বক্সে চ্যাট আসতে থাকবে। ওকে, নাও ইউ জাস্ট সি হিয়ার, জাস্ট এ মোমেন্ট। Now the screen is visible. Hello.
Yes, sir.
Okay, fine. So here you can find that this is the carbon anion. So as you know, the carbon atom is bonded to 3 atoms, as well as it is having one extra lone pair of the electrons. So naturally it is going to be sp3 hybridized. You know that, and the shape is pyramidal due to the lone pair of the electrons, just like ammonia. Then you can find the inductive effect, destabilization. As you understand, the stability of actually carbocation and stability of the carbon free radical, as they are having electron deficiency, there you find that the stability order is going to be from methyl carbocation or rather methyl carbon free radical, both. It is going to be less than that of the ethyl carbocation or the ethyl carbon free radical 1 degree, and it is going to be less than 2 degree carbocation or 2 degree carbon free radical, and then it is going to be less than 3 degree carbocation or carbon free radical. So therefore you are finding both for carbon free radical and the carbon cation, the relative stability order is going to be from methyl to 1 degree, from 1 degree to 2 degree, or 2 degree to 3 degree. However, when you are finding in case of relative stability of carbon anion, you are finding just opposite 10, because already the carbon atom is having the negatively charged. So naturally you are finding methyl carbon anion is having higher stability than 1 degree. That means order is going to be just in the opposite direction for carbon anion relative stability. So therefore you are finding the methyl carbon anion is going to be greater than 1 degree carbon anion, and 1 degree carbon anion is greater than 2 degree alkyl carbon anion, and 2 degree is going to be greater than 3 degree alkyl or so. Okay, then you understand the basicity of carbon anion. Why basicity of the carbon anion? It is understandable, because look at here, the carbon anion is already the electron enriched, so it acts as a strong nucleophile. Even if you look at with the ammonia, you know, this is also a base, weak alkali. Okay, because it is having the extra lone pair of the electron, but you just see here carbon anion abstract the proton from ammonia, and it is forming R3CH, and then you are finding NH2. So therefore you are finding a carbon anion has a negative charge on its carbon atom, making it a more powerful base and stronger nucleophile than an amine. So a carbon anion is sufficiently basic to remove a proton from ammonia. Whether this part is clear, this part is totally new, I feel, because you might not have idea this. হ্যালো দেবলীনা, শুনতে পাচ্ছ?
হ্যাঁ, স্যার শুনতে পাচ্ছি। এটা আরেকবার বলবেন?
হ্যাঁ, what I'm telling you, you just see a carbon anion has a negative charge on its carbon atom. Okay, so naturally it acts as a strong nucleophile or Lewis base. which are capable of donating lone pair of the electron. So naturally, you just see when even it reacts with the ammonia, ammonia is already, this is also a neutral nucleophile as well as the Lewis base. But you see that the carbanion is abstract a proton from ammonia to produce R3CH and the amine molecule, actually amine. So here you can find a carbanion has a negative charge on its carbon atom, making it a more powerful base and a stronger nucleophile than an amine. And that's why you're finding a carbanion is sufficiently basic to remove a proton from ammonia. Okay. Then reaction involving carbanion. Actually, reaction involving carbanion, you will study when aldehydes and ketone, mostly. You just see the reaction involving carbanion as nucleophile, the alpha halogenation of ketone, the nucleophilic addition to aldehyde ketone, aldol and cross aldol, aldol related. These are very, very important reaction. Then you will find Grignard synthesis of the alcohol. Okay. Then you will find Grignard reagent, some idea you are having already. You had studied under alkyl. Okay, no, that you will, to some extent, you had some idea under alkane, but otherwise, you yes, under alkane I explained. But under alkyl halide, you will study, and then again, you will find the application of the Grignard reagent for the synthesis of the alcohol from various type of ketone and aldehyde. Then you will find the nucleophilic acyl substitution reaction. These are the different terms. Then SN2 with alkyl halides. Okay, that you will find the Corey-House reaction. Metal. These are the all this actually you will find. Then the free radical. Already you are familiar. The carbon free radical, the odd electron neutral species, which are formed to be by homolytic. Very, very important. And the orbital structure, you know that it is bonded to 3 carbon atom and 1 electron is there. So naturally, it is going to be generally sp2 hybridized. Okay, mostly you will find. Exceptional case, you will find sp3. And the relative stability already you have explained. They just like carbocation, a 3 degree carbon free radical is more stable than 2 degree, 2 degree is more stable than 1 degree, 1 degree is more stable than methyl. And the same, we explained that in case of the carbocation stability order, either by hyperconjugation or inductive effect or resonance, the same way you can explain it. The stability order of carbon free radical, because the stability order of carbon free radical is same as the stability of carbocation. Then you will find reaction involving free radical. Already you know that when halogenation of alkane takes place, that is by free radical substitution reaction. Similarly, when you find the addition of HBr to unsymmetrical alkene like propene in the presence of peroxide, that follows free radical addition reaction. Already you are familiar with that. Okay. Then the carbene. Carbene actually you will find it can act as both electrophile and nucleophile. Suppose in case of the you will find benzene reaction of the phenol actually for salicylaldehyde or salicylic acid. There you will find the carbene free radical which act as an electrophile also. Okay, carbene you will find not free radical, it act as the actually you will find the electrophile also. Then orbital structure of the singlet carbene, that is sp2 hybridized. Then you will find the orbital structure of triplet carbene, that is sp. These you will not be able to understand at this very moment, but gradually you will be able to understand. So I'm not going for that in detail. Okay. These are the reactions. Hello. Hello everyone.
Yes, sir.
Yes.
hello sir.
আজকে এই পর্যন্ত থাক প্রথম দিন। আমরা নেক্সট দিন আমরা ওই কলিগেটিভ প্রপার্টির সলিউশনটা করব on Sunday, and then next Tuesday we will study the organic chemistry. Instead we will start with the haloalkane and haloarenes. Any question? Oh, next Tuesday we will study organic chemistry. Okay, right, that we will study organic chemistry next Tuesday. Okay.
Okay, sir.
Okay, fine. So okay, you can leave the class.